All right, so to do this, we have defined our variables. L is the length, W is the width. We read that the length is 8 centimeters more than the width. That's how we got W plus 8 equals L. So we are labeling our diagram, width on the sides, length on the top and bottom, but instead of using L, we use W plus 8. Next, we have to set up some sort of equation. We need to use this idea of perimeter that they included. How do we find perimeter in general? Somebody new. Somebody I haven't heard from yet today. Yes, sir. Add up all the sides. So I'm going to add up all my sides. W plus 8 plus W plus 8. Okay, we got all 4 sides here. And that's going to be set equal to my perimeter, which they told me is 64. In order to solve this, Lexi, what should I do?
Add like terms.
Very good. We are going to combine like terms. When I combine like terms, I have 4 W's that I'm adding together. So 4W plus 8 is 16. Would somebody like to raise their hand and explain to me how to solve this? Ryan.
So first, I'm going to subtract 16.
Okay.
And 64.
All right. And then what?
Divide by 4. Oh, wait.
What is that? 48? And then divide by 4.
On both sides.
Okay, so we get W equals 12. Those of you that did this one yesterday, did you get W equals 12? Good. But are we finished? No, they didn't just ask for the width. What else did they want? The length. How am I going to find it? Add 8. We said in the very beginning the length is the width plus 8. So in order to get the length, I add 8, I get 20. We should have units on these, centimeters. And that's our answer. Number 8 says a lion can run 18 miles an hour faster than a giraffe. If a lion can run 50 miles an hour, how fast can a giraffe run? Okay. So, for our variables, technically we already know one of them, but I'm just going to set it up. So L will represent the lion rate. You could use something different, like how fast a lion goes, or lion's pace, but rate would be the mathematically best word. And G is going to represent the giraffe's rate. So we have to define our variables first. Okay, so then it says a lion can run 18 miles an hour faster than a giraffe. This is tricky because they don't use the word is, right? We are used to seeing the word is to know where to put our equal sign. But if I were to replace the words can run with the word is, would this still make sense? A lion is 18 miles an hour faster than a giraffe. Okay, so I can think of this part as my is. Does that make sense? That's where my equal sign goes. So L equals 18 miles an hour faster than. What operation do you think we want? Addition. Like 18 miles an hour more than. It's the same idea. So we'll take a giraffe rate plus 18. This one now turns a little bit easier because now they tell us the lion can run 50 miles an hour. They gave us one of those numbers. So do you think 50 is going to get plugged in for L or G? L. A lion can run. So L, that's my lion. So 50 equals G plus 18. And we got that because they told us that the lion could run 50 miles an hour. Now this one ends up being a lot easier to solve. What do I have to do to both sides? If I'm trying to solve for G. Subtract what?
18.
Subtract 18. So how fast can the giraffe run? I think I heard somebody say it. 32 miles per hour. Good. Don't forget your units. All right, on 10 and 11, we're back to using the idea of consecutive integers. And on number 10, we're talking about consecutive even integers. So my variable for this one I'll define as x, and it's just going to represent an even integer. X is going to be an even integer. Find 3 consecutive even integers whose sum is 96. The word sum means I'm doing what? Adding. So I'm adding 3 numbers together to get 96. So I'll leave a space for my first number, my second number, my third number. When I add them together, I should get 96. Now my first number is just going to be x. That's my first even integer. If you look in that little box on the top of your notes page, it says to get to the next even consecutive integer, what do? X plus 2. We add 2 to get to the next even integer. But then we need another even integer after that. So we added 2 to the first one. If we add 2 again, how many are we adding altogether? If we add 2 to the middle number. No. We added 2 here. So if we add 2 more, how many are we up to adding? 4. So to get to another one, we have to add 2 again. So now we're adding 4 to x. Alright, so let's erase that down there. Now we've got an equation set up. That's the hard part. The easy part should be solving. Ellie, what's my first step to solve? Good. You add like terms. Okay, so when we add like terms, how many x's do we have? 3. So we have 3x plus 6. 2 plus 4 gave us 6. That equals 96. Who would like to raise their hand and tell me how to solve the rest of this? Deja.
You're going to subtract 6 from both sides.
Okay.
And then you're going to get 90.
All right.
90 divided by 3.
90 divided by 3 is 30. Okay, so we had to set up our equation and then solve it by using our inverse operations in the reverse order. But we're not done quite yet. Alright, so we're not done yet. They wanted us to find 3 consecutive even integers. We just found the first one. What's going to be the next even integer after 30? What's the next even number that comes after 30? 32. And what's the next one after that?
34.
Okay. Those are the 3 numbers they wanted us to find. So you can plug them back in. So we found 30, so then we take 30 plus 2, and then we take 30 plus 4. It's another way of coming up with them. But if you know what even integers are, you can just think about it and come up with them. All right, last one. Find 4 consecutive odd integers whose sum is 72. This one's going to be very similar to the last one. X will represent an odd integer this time instead of an even one. Again, sum means I am adding, but this time I'm adding how many numbers? 4 of them. So space 1, 2, 3, 4, and when we add them up we get 72. Now my first one is going to be X. My next one, if I'm going to the next odd integer, what does it say in our notes to do? Add 2. I know it seems weird that we do the same thing for both even and odd, but if you think about trying to get from 1 to 3, you still just add 2, even though they're both odd. So if we start with an odd number, we're still adding 2 to get to the next odd number. So what do you think it'll be for the next one? X plus 4. And what about for the next one?
X plus 6.
Good, we're catching on to these patterns. So our numbers are x, x plus 2, x plus 4, and x plus 6. Much like the last one, our first step is going to be like terms. How many x's do we have?
1.
If we add all those constants, what do we get? So we have 4x plus 12 equals 72. Kion, can you walk me through solving the rest of this? Okay. So that gives us 4x equals 60. All right, Kion, what comes next? Very good. And that gives us x equals 15. But they don't just want that first number, they want all of them. What's the next odd number?
15.
What's the next odd number? And the next one? Alright. So we have our 4 consecutive odd numbers that if we were to add them all up, we would get 72.